I benchmarked a CPU with active natural cooling and it showed 8% performance boost. I didn't change anything in the system, nothing at all. And the FPS in the game skyrocketed. I'll show you the difference a little later. So, are we going to play games with a hat on now? In this ad-free and honest video, let's take a look at how a cooling system affects PC performance. I'll tell you about my own experience with my computer slowing down and then speeding up depending on how I use thermal paste, an experiment with thermal interface materials, what you need to know about thermal paste and thermal gum or thermal pads, and how this affects performance, especially in programs and games. I found it very interesting and I hope you enjoy it too, but the main thing is that it's useful. First, I'll tell you about the experiment and then draw some conclusions that can be applied to other computers. Of course, cooling systems vary from PC to PC, but we'll try to extract some useful principles that can be applied across the board. How did the idea for the experiment come about? When I was making a video about testing the Windows 11 25H2 and 22H2, I noticed that the laptop's performance had dropped compared to when I bought it about 3.5 years ago. There were several theories about why this was happening, but now I know for sure. That it's the cooling system, and the cold test is a good way to analyze the cooling system. If your performance increases in cold temperature, then it's time to do something about it. How does it work? Processors like mine, I have an Intel Core i5-11300H, use Turbo Boost technology. The standard frequency is 3.1 GHz, but it can dynamically increase it to 4.4. In other words, the processor automatically overclocks if it has the incentive and the ability to do so. One of the options is temperature headroom, as it can't go above 100 degrees Celsius to maintain performance. Let's launch a demanding game, the boost is enormous, the processor is utilizing 100% of its capabilities, but if the frequency is high, the temperature jumps to 97 degrees Celsius, which is extreme. The processor realizes that the cooling isn't keeping up and cools itself by reducing the frequency. And if the frequency is reduced, performance drops. It's a direct correlation. It's the same story with the GPU. If you have a good cooling for GPU and its memory, their performance will also be significantly higher. Let's move on to experiments. We'll test the processor using the Cinebench benchmark, we'll run several tests in each situation to reduce the error. And the graphics will be tested using Manor Lord's game. This gives me good opportunities for measuring FPS. And the situation 1. All components under the heatsink are coated with Arctic MX4 thermal paste. The layer isn't the thinnest, but I later discovered that this thermal paste is quite flexible. It doesn't dry out when heated, remaining fluid, which is good. The manufacturer doesn't specifically provide thermal conductivity, but the website states that no thermal paste can provide more than 4 watt per meter Kelvin. Let's assume that about right. So I already learned it's not recommended to apply thermal paste to video memory. Well, it's good that mine survived this experiment. We are running tests on Windows 11 25H2 and 22H2, but I'll focus on 22H2. It's cleaner, more optimized in my case, and delivers higher results. In the benchmark, we get 19 points, and in-game we get 45 FPS when zoomed in and 53 when viewed from above. Next, we don't change anything in the Windows settings, we just change the thermal interface. And the situation 2, I decided to buy a liquid thermal pad, also known as thermal gum. I chose this Sub-Zero LTP15, which has a thermal conductivity of 15 watt per meter Kelvin, but I don't know how much it actually is. I'm coating all the components with it in this experiment. The thermal conductivity is definitely 2-3 times higher, and this material has a different density. When heated, it literally becomes like chewing gum. What will change now? The temperature is immediately lower, especially on the graph, and the FPS has significantly increased. Now we have 60 when zoomed in and 90 when viewed from above. That's a 33% and 51% increase, with an average of 40%, and that's quite significant, you'll agree. The processor has also improved. The very first benchmark show 5753 and the maximum was 5853. This is also a very pleasing 8% increase. And this value is even higher than during my test on a new laptop in 2022. Interesting, when I consulted with ChatGPT, they tried to dissuade me, insisting that liquid thermal pad shouldn't be used on chips, as it's dangerous because it might start conducting electricity when heated. But this particular model isn't conductive. It's not liquid metal and it doesn't spread. It's like chewing gum in consistency. And the chat, like some expert in the comments under the previous video about cooling, advised using thermal pad on video memory modules and voltage regulators and thermal paste on processors with a minimum layer for better contact between metal surfaces. Well, let's try this, but I won't touch the GPU. I'm happy with it, the cooling works perfectly. So situation 3 is thermal paste on the processor. The other components have gum. Everything is as it should be, we do it, we assemble, and then we go back one step. The processor has become less cool, the clock rates are lower, and therefore performance is lower. The benchmark shows 5378, but in the game it's 46 FPS when zoomed and 70 at maximum. Bad. The processor is overheating and everything else is crumbling behind it. Even though the GPU plays a major role in the game, the frame rate still drops. So here is the conclusion. The material we used to ensure heat transfer from the processor to the heatsink doesn't just affect system safety. It significantly impacts performance. So friends, if you want to speed up your PC by a few percent or maybe even 50%, like my FPS increased in the game, then consider not only optimizing Windows, but also proper cooling. While winter is here, you can test your computer in the cold, and if improvements are needed, consider and seek advice on how to do so. For example, my processor and its weak cooling system, both thermal paste and thermal pads, are not enough. At high frequencies and voltages, the processor can't maintain its operating temperature for long. Its maximum clock rate is 4.4 GHz, and it can even maintain 4. I'd like to provide it with more cooling at race to raise the clock rate. I don't like the active cooling option with a special stand, it's inconvenient. The chat also recommended a phase change thermal pad. Experts, please leave your comments on this. Will this provide better cooling, or is it useless with a design like this? Also friends, if you watched to the end, you probably enjoyed the video. Please take another 10 seconds and leave a comment. And also check out other videos on my channel about optimizing Windows 10 and 11. Speed up your PC even more.